a few, like not a few, anyway, fabricas like this, and then we have fabrica like this, and then we have another spaghetti like this, and one this, and one this, and all connected through electromagnetic waves, or for example, different gravity, even for example, gravity as we define, it is like losing the fabricas, right? It creates, movement of fabricas. So in this world, X, Y, and Z are not as we understand and define in physics, current physics. So basically, we should change this and then understand it in exactly different system, different model. The space itself changed.
What is the coordinate of this underlying space? You say?
Okay.
Z1 is the coordinate of it?
No, Z1 is basically fourth dimension. We define it basically to show how two waves can actually collapse, even cancel each other, and they can actually, because for example, let's say this fabrica is like having another like fabrica like coming to, it's like wave canceling each other, or in a constructive manner or deconstructive manner they cancel each other, and then they end up in a different shape. You know what I'm talking about? Like let's say two groups are handshaking here, and then this group and then that group will continue to handshake all together.
Yeah, clouds merge.
Yes.
Kind of.
Yes.
Yeah, it's kind of cloud.
Yes.
Cloud.
Merging clouds and also splitting the clouds. Like light that is like splitting in different colors. Also, we can, for example, if we are 10 people here, we can actually like have 3 person, like 3 group of 3 and group of 4 and group of 3 getting splitted with different, for example, people that they are moving their hands faster, they end up together. And medium group and a slow group.
High energy group and then.
This is exactly what is happening in light. So basically we can split the fabrica handshaking into a smaller groups and or merge it to the bigger one.
So this is kind of hidden kitchen of the matter propagation.
Yes. And now why it is useful in entanglement and everything? Because then we have full like factor of time completely addressed by this interpretation. Why factor of time is important? Because of entanglement and because of basically a photon starting as particle 1 million years ago, because today we are observing it. You remember that was a space and time together. So if it is if the handshake happened, we are already we are connected to the past of that star, and that star basically connected to the future, which is today of us.
So everything is known immediately.
Immediately, exactly.
And here.
Yes, right now, right here.
You don't need to go and look.
Yes.
Yeah, what Bohr said that what matters for physics is just what we can measure. This is Copenhagen interpretation.
Yes.
Everything else is
that
how one can indirectly measure that theater, hidden theater.
Mm-hmm. Now, if we measure something, we collapse this handshake.
Then starts official physics.
Exactly.
Yeah.
So we split it again to the basic fabricas. Why this can address the issues that currently we face with the crisis between general relativity and quantum physics, because the time in quantum physics is a problem. Like whatever, if you are even talking about entanglement, what was the factor here, the problem to solve? There is time. What happened? They are connected. Like it seems they are like connected.
Double slit.
Yes.
Can see future.
In this, because fabrica is already has the time factor in it, and when we create a large basic, and there is one interesting basically fact. In quantum, they say, for example, you have a wave as big as universe, and you collapse the wave by observing it. Here, the wave, the other side of the wave, on the other side of the universe will collapse immediately. Correct? Not by the speed of light. This is part of quantum physics, correct? It says if it is this is a wave, okay? You observe something here.
Yeah.
You observe it here, like for example a million year, like a billion year bottom. The whole wave will collapse, not just this part of the wave that you observe. The whole wave will collapse, and by this definition, because time is the same thing in this side of the Barpa effect and the other side of Barpa system and the other side of Barpa system, the collapse will be immediate because there is no time between these two.
So it's
yes.
Overall.
It is the same place.
Yeah.
Exactly.
So this is a problem for quantum mechanics.
Which is we solved here.
Which could be
And we call it Tablis interpretation. Makes sense, doctor?
I mean, physics position is that until you measure something, you should measure something to say that it is.
This is all about measurement and collapsing the system. Barpa system will collapse immediately as soon as measured.
Yeah, collapse.
Because it will convert to the normal measurement system that you have. This is the normal measurement system. This Barpa system is not defined by this.
No, it is what is.
Yeah.
This is where you measure.
Yes, when you measure it,
at that point, then you measure it.
When you measure it, this Barpa system will collapse completely. To one small fabrica. And it can end up here or there or there or there. But why? Also, answering a very important question. Why this Barpa system, let's say this is a strong line, this is a smaller line, this is a smaller line, this is weight, right? For example, this is very strong. And this one is smaller and smaller and smaller and smaller. This is a probability of the wave. So if you are actually
on the screen.
Yes, on the screen of double slit. Basically, if you are shooting protons.
Interference.
Yes.
Picture.
But what is this? This is exactly the shape, the shadow. That is a very non-scientific word. I'm going to use it. The shadow of Barpa system that photon is creating. This is the shadow of that. So every time I'm shooting a photon, a Barpa system similar to this will create, which has it is like this. It is like an animal like this with a very big leg and two small legs and a few smaller legs. Okay? And basically because it is wave and wave in the wave. And therefore, because this part is bigger of this animal, there is more probability that when I collapse the system, it ends up here, then here, then here, then here. That's why the elastic works like that. So there is a dilemma also in quantum physics. If you shoot one photon and then go and tomorrow come back, tomorrow, and shoot another photon, and then go and tomorrow come back and shoot another photon.
There will be the same picture.
Will be the same picture. This shows it is not just a wave that is created. These are not related, the photons, correct? Why this is happening? This is also another problem that quantum physics is supposed to solve. Because when we are shooting a photon, the properties that photon has creates the fabrica always look like this.
So that tells you that one photon doesn't care about other photons to go where it wants.
Yes, it creates the same Barpa every time. The photon creates same bar every time, and then because the probability of ending up here is more than here, and here is more than here, therefore tomorrow you will see that shape getting more and more completed. So basically you created 1 million, let's say, BARPA, and collapsed 1 million BARPA, and you are seeing the shadow of 1 million BARPA in here, but each one different. Each one created and collapsed already. Each one created and collapsed, created and collapsed, created and collapsed. So basically each particle creates its own BARPA, created and collapsed. So we see it as a wave because the behavior